following a B-2 strike on Iran's largest power facility, crippling its central control systems. At 6:15 local time, the U.S. Navy's Fifth Fleet moved into the Strait of Hormuz to reopen the passage and restore global oil flow. But the fleet faced a critical obstacle. Iranian forces had laid underwater mines across the strait, effectively blocking all maritime traffic. This was not a single hazard. It was a controlled field. The mines had not been scattered at random. They had been laid in structured lines spaced across the seabed in calculated intervals, some resting on the ocean floor, others anchored just below the surface. Multiple rows extended across the corridor, forming a layered field designed to control every movement through the strait. Clearing them would be one of the most dangerous phases of the operation, requiring precision, patience, and time the fleet did not have. The longer the fleet remained in place, the more exposed it became. Modern naval mines are not the simple floating contact devices of past wars. Today's mines sit on the seabed or are anchored at a set depth below the surface, invisible from the deck of a ship. They use a combination of sensors, magnetic, acoustic, and pressure to detect passing vessels. A magnetic sensor picks up the metal hull of a ship. An acoustic sensor listens for the sound signature of engines and propellers. A pressure sensor detects the change in water displacement beneath a moving vessel. Combined, these systems allow a mine to detonate under a ship without any physical contact. Some were configured with layered triggers. Some were designed to ignore smaller disturbances. Others were not. In a field like this, assumptions could be fatal. While the underwater drones scanned the wider area, situations requiring precision work called for human divers. But they were not searching blindly. Each movement was guided by contacts already flagged by sonar and unmanned systems. In their quarters below deck, Navy explosive ordnance disposal divers suited up. They pulled on their wetsuits, strapped on their breathing apparatus, checked their equipment dive computers, underwater lights, communication gear, tools. The preparation was methodical. No movement wasted. Some of these mines were sensitive enough to detect even minimal disturbances in the water. For the divers, that meant strict control low magnetic equipment, closed-circuit rebreathers, and slow, deliberate movement. No bubbles, no unnecessary motion, no second chances. Once ready, they climbed into rigid hull inflatable boats and moved toward the coordinates flagged by the scanning teams. While the divers moved out to their dive site, the rest of the operation maintained full defensive posture. Soldiers on the ship stayed behind their machine guns, eyes on the sky and water. Lookouts with binoculars swept the horizon in continuous rotation. The fleet reduced speed to a minimum. At high speed, the risk of running over an undetected mine was too great. At low speed, the ships became exposed limited maneuverability, confined space. No margin to evade if a threat appeared. This was the most vulnerable moment of the operation. All onboard sonar systems and mine detection scanners were active, sweeping the water ahead and below the hulls. The cruisers and submarines in the group were brought to full combat readiness. Anti-air systems tracked the skies for Iranian drones and incoming threats. Helicopters launched from the carrier and began flying patterns over the water ahead of the formation. Some scanned the surface. Others towed sonar sleds through the water, mapping the seabed in real time, sector by sector. Every movement was deliberate. There was no room for improvisation. The divers reached their location and entered the water. They descended along the coordinates provided by the sonar team. Visibility was limited. The seabed was uneven, covered in reef structures and debris, perfect conditions for concealment. They moved slowly, using their lights to scan the terrain. Then, they found it. A mine wedged deep in the coral, partially buried in a position where an unmanned vehicle could not safely maneuver. But it wasn't alone. Additional contacts had already been flagged nearby, spaced across the seabed, indicating a wider minefield extending beyond the immediate site. The danger wasn't just the mine they could see. It was the ones they hadn't found yet. The divers conducted a close visual assessment, confirmed the type and condition of the mine, and reported back to the ship through underwater communication systems. The decision was made not to attempt manual disarming. In a field like this, the spacing, positioning, and the possibility of layered triggers introduced unacceptable risk. Any direct interaction could set off a chain reaction. Instead, the divers marked the location and ascended back to the surface, putting distance between themselves and the mine site. From the ship, the crew deployed a work-class remotely operated vehicle designed for precision inspection in confined underwater environments. The vehicle was equipped with high-resolution cameras, sonar imaging systems, and manipulator tools. It was lowered into the water and guided by an operator watching a live video feed on a monitor. The vehicle descended toward the mine's location, moving slowly across the seabed. It confirmed the mine's exact position, orientation, and condition in real time. Inside the operations room, the commanding officer, the EOD team leader, and the sonar operators watched the same live feed. Every detail was visible, every movement controlled. Once the contact had been verified and the risk assessed, the decision was made to proceed with remote neutralization. A second system was deployed, a compact, single-use disposal vehicle purpose-built for mine destruction. Smaller and faster, carrying an integrated explosive charge, it was guided directly toward the target. The vehicle approached carefully, aligned beside the mine, and positioned the charge. The operator confirmed placement. The vehicle then backed away to a safe distance. Seconds later, the detonation sequence was initiated. A muffled underwater explosion sent a column of water and debris upward. The mine was destroyed. The sonar team confirmed that the contact was gone, but no one assumed the area was fully clear. In a field like this, clearance was never absolute, only risk reduced, only a navigable corridor established. On the lower decks, ammunition handlers brought up crates of belted rounds for the deck-mounted heavy machine guns. The belts were unpacked, inspected, and carried topside. The ammunition was fed into the guns and locked in. The gunners charged their weapons and fired short test bursts over the water to confirm readiness. These weapons served a dual purpose, engaging aerial threats and detonating floating mines at a safe distance. The fleet continued forward, slow, controlled, exposed. No alarms sounded, no warnings were given. In operations like this, the most dangerous moments arrived without noise. Beneath the surface, the threat remained unseen, partially detected and always present. Somewhere ahead, another contact waited,